Here's another problem on the remainder theorem, and that states if we take a function and we divide it by x minus b, a linear binomial, then the remainder is the same as if I was to take the opposite of minus b and plug it into the original function. And we're going to make that calculation and do the division just a second, check it on Desmos. So let's say I've got this big long polynomial right here, and I wanted to find the remainder if I was to divide by x plus 8. The remainder theorem just simply says take x equals to -8 and plug it into that equation, and that'll give us the remainder. Let's go ahead and do the division and check it on Desmos to make sure we're doing this correct. So I went ahead and set up our area model, and it's already ready for division. So let's start. I'm going to take the x to the 4th. I'm going to slide it in, and then I'm going to slowly work on that division. So this becomes an x cubed. After that becomes an x cubed. I'm going to say x cubed times 8, which is 8x cubed. Now remember, this box plus this box need to add to that 9x cubed, and we're going to say that must be 1x cubed. And then once we have that, I'm going to say, okay, well, x times what is x cubed? That is x squared. So x squared times 8 is 8 x squared. Now at that point, I say, well, what do I add to 8x squared right here to get that 14x squared, which is going to be 6x squared. Once I have that, say, okay, x times what is 6x squared? Well, that is 6x. Okay, 6x times 8 is going to be 48x, so 48x. And I'm going to say, well, what do I add to that 48x to get that 50x? So that's got to be 2x. And then I come back and I say, okay, well, 2x times x is 2. That's the only way that can happen. And then I have 2 times 8, which is 16. Now the question is, what do I add? These are not the same. So how do I make them the same? I have to have a remainder. So what do I add to 16 to get the 9? That's got to be -7. Okay, -7 plus 16 is going to give us a value of 9. So now the remainder we are looking for is -7. And the remainder theorem just simply says, again, if I take the opposite, of this value in the binomial, linear binomial here, and I plug it into the original, I should get that remainder of -7. So let's go to Desmos. I've plugged in the equation, x to the 4th plus 9x cubed. You'll notice that if we look at this, remember what we're looking for is we are dividing by the binomial x minus 8. Okay. Oh, let me go back. X plus 8, I'm sorry, let me change that. So we are dividing by the binomial x plus 8, okay? And remember that x plus 8 is showing right there, but it looks like it's crossing the x-axis right there, okay? So it looks like it could be a factor. Well, let's go ahead and take a peek. I'm gonna put f of -8 in there, which is the opposite, and check it out. There's my value of -7. So why is it that it looks like it should be a factor? Well, look at the scale over here. It's huge. So if we scroll in, right now and get closer and closer into that, you're going to notice, check it out, it doesn't hit directly at -7. In fact, if I put x equals to, at -8, if I put in -8, it does in fact hit right there, showing us a remainder of -7. So once again, with the remainder theorem, we take that binomial that we're dividing by, which is in this case +8. We flip it over to its opposite and we plug it into the original function, and that will give us our remainder.